Saturn is the sixth planet from the Sun and the second largest in the solar system. As a gas giant, it has nothing that can really be considered a surface, but it likely has a small core. This planet has the most moons at a grand total of 146, and it's most well known for its stunning rings. Like its fellow gas giant Jupiter, Saturn is a massive ball made mostly of hydrogen and helium. Saturn is the farthest planet from Earth that was discovered with the unaided eye, and it's been known since ancient times because of its visibility. Ancient people saw it as a wandering star, like they did with the other planets in the solar system, and they also noted that it was the most slowest moving. It's named for the Roman god of agriculture and wealth, who also happened to be the father of Jupiter. Saturn's Greek equivalent is the Titan Cronus. Saturn itself is very unlikely to support any life. Its environment is pretty hostile to life as we understand it. Some of its moons could be suitable for life, though. Like the rest of the solar system, Saturn formed about 4.5 billion years ago, and it settled into its current position about 500 million years later. The pull of its gravity has helped shape the solar system's history and fate. Along with Jupiter, it might have helped to throw Neptune and Uranus further out. It also could have tossed a bunch of debris at the inner planets during a period called the Late Heavy Bombardment early in the solar system's history. A study in 2017 suggests that Saturn steers dangerous asteroids away from Earth even more than Jupiter does. Come along with me as we take a closer look at the ringed planet. Saturn orbits at an average distance of 886 million miles away from the Sun. At this distance, light takes about 80 minutes to reach Saturn from the Sun. That's over an hour and about 10 times as long as it takes for light to reach Earth. Speaking of Earth, Saturn's closest distance to it is about 746 million miles, which, that's pretty far. Saturn has the second shortest day in the solar system at just 10.7 hours. The fact that this thing is spinning so fast causes it to bulge at the equator and flatten at the poles, giving it an oblate shape. This shape is visible through even a small telescope, which makes Saturn the most oblate planet in the solar system. Saturn's rotation period, or the time it takes to spin once on its axis, was very difficult to determine. The motion of clouds in its upper atmosphere give us a variety of periods to work with. Some are as short as 10 hours and 10 minutes near the equator, but the time generally increases to about half an hour longer at latitudes higher than 40 degrees. Because the clouds were obviously unreliable, scientists instead tried to find the rotation period of Saturn's deep interior using that of its magnetic field. This field is presumed to be rooted in the planet's metallic hydrogen outer core, but the direct measurement of the magnetic field's rotation period is difficult to find out because it's highly symmetrical with the planet's axis of rotation. At the time the Voyager mission encountered Saturn, radio outbursts from the planet that are apparently related to small irregularities in the magnetic field indicated a rotational period of about 10 hours and 39.4 minutes. This value, for a while, was taken as the magnetic field's rotation period, but 25 years later, measurements taken by the Cassini spacecraft indicated the magnetic field was actually rotating with a period 6 or 7 minutes longer than originally thought. The solar wind was blamed for the differences between the measurements from Voyager and Cassini. Saturn's rotation period was finally accurately measured when Cassini flew into its rings on its final orbits. It was determined to be about 10 hours, 33 minutes, and 38 seconds. This measurement came from the study of some of the planet's rings. A fully accurate and reliable estimate of Saturn's rotation period still hasn't been established, though, despite scientists' best efforts. The time difference between the rotation periods of Saturn's clouds and its interior has been used to estimate the planet's wind velocities. Scientists do the same thing to figure out the speed of Jupiter's winds, too. Saturn makes a complete orbit around the Sun every 29.4 Earth years, which is pretty long. It also experiences seasons that are each more than 7 years long because its axis is tilted 26.73 degrees. The exact reason for this tilt is kind of unknown. With Earth and Mars, we can see that their tilts came from impacts, but Saturn is a gas giant. The most common theory for a while has blamed gravitational interactions with Neptune for Saturn's tilt. At one point, the tilts of Saturn and Neptune are thought to have been in some kind of resonance with one another, and this resonance was maintained by a moon of Saturn that no longer exists. This moon could have gotten too close to Saturn, which caused it to be pulled apart by its gravity, and thus removed Saturn from its resonance with Neptune and left it with its current tilt. Saturn has a diameter of about 74,897 miles, which makes it 9 times wider than Earth. Like Jupiter, another gas giant, it's mostly made of hydrogen and helium. A lot of information about Saturn's interior comes from studying its gravitational field, which isn't spherically symmetrical. The planet's rapid rotation and low density distort the shape of the gravitational field, just like they do for the planet itself. Saturn has several layers, but pretty much all of them are just made up of hydrogen in different forms. At the center is a dense core of metals like iron and nickel, which is surrounded by rocky material and other compounds kept solid by the intense pressure and heat. This whole thing is enveloped inside a layer of liquid metallic hydrogen, which is inside a layer of just regular liquid hydrogen. The layer of metallic hydrogen is where the planet's magnetic field is thought to come from. The core of Saturn is probably pretty similar to Jupiter's, since we can't directly observe either. We can't really tell exactly what either one is like, but much smaller. Saturn's atmosphere and clouds are made of hydrogen, helium, water, and small amounts of some other gases like ammonia and methane. It's the only planet with an average density lower than that of water, with Saturn's density being about 70% the density of water. That means that if you could find a giant cosmic bathtub big enough to fit this thing, Saturn would float on the water. As a gas giant, there's no true surface to Saturn. The deeper you go, it's mostly just swirling gases and liquids. It would also get really hot and there'd be a bunch of pressure, so maybe don't go there. That's a bad idea. You wouldn't be able to get a spacecraft to land on Saturn, and it couldn't just fly through unharmed either. The extreme pressure and temperatures deep inside the planet would completely crush, melt, and vaporize any spacecraft. So basically, we're just probably never going to see what the inside of Saturn looks like. When viewed from Earth, Saturn has a hazy yellow-brown color, although it's actually many different shades of yellow, gray, and brown. It does have stripes similar to Jupiter, but these stripes don't vary as much in their appearance and color, and so they're harder to see. These stripes come from clouds that also appear as jet streams and storms. The atmosphere is composed mostly of molecular hydrogen, that's H2, and helium. The current estimate says helium makes up about 18 to 25% of Saturn's atmosphere by mass, with most of the rest being molecular hydrogen and about 2% being other molecules. For the most part, Saturn is made of a lot of the same materials as the Sun, which again is pretty similar to Jupiter. Saturn has 2 to 7 times as much methane and ammonia relative to the amount of hydrogen, though. The yellow and gold bands in Saturn's atmosphere come from super fast winds in the upper atmosphere combined with heat rising from the interior. In fact, Saturn probably has some kind of internal heat source because it gives off way more heat than it receives from the Sun. Just like Jupiter. There sure are a lot of similarities between the two, huh? Saturn's winds are measured with respect to the rotation period of Saturn's magnetic field. Winds in the upper atmosphere can reach speeds of 1,600 feet per second around the equator. That's close to 1,100 miles per hour. Winds on Earth don't get anywhere near that speed. At Saturn's North Pole is an interesting feature of its atmosphere, a 6-sided jet stream. This hexagon-shaped pattern was first noticed in images from Voyager 1, and it was later more extensively studied by the Cassini spacecraft. It's a jet stream of 200-mile-an-hour winds. It spans about 20,000 miles, and there's a massive rotating storm at its center. There's no other weather feature quite like it anywhere in the solar system. Occasionally, Saturn has what are called great white spots, which are named in reference to Jupiter's great red spot. These are periodic, huge storms seen in Saturn's atmosphere. They don't last very long, and they're thought to be related to the seasons because they generally occur in late northern summer. That's summer in the northern hemisphere. When I sat here writing the script, I tried to think of a way to end this section neatly and cleanly, but I couldn't. So this will have to be good enough. Let's move on now. Saturn's magnetosphere is the teardrop-shaped region around the planet in which the behavior of charged particles is dominated mostly by the planet's magnetic field instead of the interplanetary magnetic field. Saturn's magnetic field is much smaller than Jupiter's, but still many, many times more powerful than Earth's. The polarity of the field is opposite from that of Earth. The magnetic field lines emerge in the northern hemisphere and re-enter in the southern. This means that a common magnetic compass on Saturn would point south instead of north. The magnetic field is generated by the fluid motions of the electrically conductive portion of Saturn's interior, by which I mean the metallic hydrogen, because the pressure in the planet is so absurd that hydrogen acts like a metal, just like Jupiter. The similarities never end with these guys. Like father, like son. Saturn, its rings, and many of its moons lie totally within its magnetosphere. The moons Titan and Hyperion occasionally cross the magnetopause. That's the boundary between its magnetosphere and solar wind. This causes energetic charged particles in the outer magnetosphere to collide with neutral atoms in Titan's atmosphere and energize them, which causes erosion of the atmosphere. Did I mention Titan has an atmosphere? Probably not, because I haven't talked about Saturn's moons yet. We'll get to that later, though. Auroras occur when charged particles spiral spiral into a planet's atmosphere along the magnetic field lines. On Earth, these charged particles come mostly from the sun, but at least some of Saturn's auroras are like Jupiter's and aren't affected by the solar wind. They're unusual because they're most visible in ultraviolet light, which is a wavelength that we just can't see. Saturn's auroras aren't fully understood yet, but they could be caused by a combination of particles ejected from Saturn's moons and the magnetic field's rapid rotation rate. And of course, I couldn't talk about Saturn without mentioning its beautiful rings. Saturn's rings were first observed in 1610 by Galileo Galilei. To him, though, they looked more like handles or arms. He couldn't tell that they were rings. 45 years later, Christian Huygens made the smarter proposal that Saturn had a thin, flat ring. 20 years after that, Gian Domenico Cassini discovered a gap in the rings now called the Cassini division, which cast doubt on this theory of a single ring. In 1789, Pierre-Simon Laplace published a theory that the rings were made up of a bunch of smaller components. In 1857, James Clerk Maxwell sort of supported this by demonstrating that the rings could only be stable if they were composed of many, many smaller pieces. James Keeler confirmed this about 40 years later. Because of Saturn's tilt, we see the rings from varying angles from Earth. A review of the rings cycles over a 30-year period. We see the sunlit northern side of the rings for about 15 years, and then the southern side for another 15. In short intervals, when Earth crosses the plane of the rings, they're pretty much invisible because we're seeing them from the straight edge on. The rings are thought to be pieces of comets, asteroids, or shattered moons that were pulled apart by Saturn's gravity before ever reaching the planet. A 2016 study suggested that the rings could also be the remains of dwarf planets that got a little too close to Saturn. Billions of chunks of ice and rock coated with other materials like dust make up the rings. The particles range from tiny dust-sized icy grains to chunks as big as a house, and some are even as large as mountains. If viewed from the cloud tops of Saturn, the rings would look mostly white because a lot of it is just ice. The largest ring spans about 7,000 times Saturn's diameter. The entire ring system extends up to 175,000 miles from the planet. Though expansive, they're very thin. The vertical height is typically about 30 feet in the main rings. That's right, I said feet, not miles. The Cassini-Huygens spacecraft observed vertical formations in some rings, which were caused by particles piling up in bumps and ridges, sometimes up to 2 miles high. The rings strongly reflect sunlight and have low mass. They're likely pretty young, between 10 and 100 million years, so Saturn hasn't had its rings for most of its history. The rings are named alphabetically in the order they were discovered from A to G. Most are close to each other, with the exception of the 2,920-mile Cassini division between rings A and B. Smaller gaps exist between the other rings, and these gaps are mostly caused by Saturn's moons. Rings A, B, and C are the main rings. C, D, E, F, and G are fainter and were discovered more recently. Starting from Saturn and moving out, the order of the rings is D, C, B, the Cassini division, A, F, G, and E. Even further out is the Phoebe ring, which is the largest planetary ring in the solar system. The ring is in the orbit of the moon Phoebe, and it's made up of dust ejected from the moon because of impacts. Mysterious spokes have been observed in the rings. They don't last long as they form and disappear in just a few hours. They might be composed of electrically charged sheets of dust-sized particles created by small meteors hitting the rings, or by electron beams from Saturn's lightning. The F ring has a curious braid-like appearance. It's made of several narrow rings, and bends, kinks, and clumps in these smaller rings give the illusion of a braided appearance. Impacts from asteroids and comets have also altered the appearance of the rings. Material from the rings can become charged through photoionization. That's when an ion or a charged particle is created through an interaction with a photon. Ring material can also become charged through micrometeorite impact. Once charged, the particles enter Saturn's ionosphere along the magnetic field lines. This means the rings are gradually losing material. At the current rate this is happening, the rings will disappear in about 292 million years. Imagine that. Imagine a future where Saturn has no rings. Humanity will almost certainly be long gone by that point, but it's still kind of sad to think about. Saturn has the most moons of any planet in the solar system at 146 as of June 8th, 2023. In fact, it has the most moons of any planet known because moons around exoplanets are very hard to spot. Of the first 18 moons discovered, all except Phoebe orbit within 2.2 million miles from Saturn. All the inner moons are regular. This means they orbit in the same direction of Saturn's rotation. Their orbit is generally within the plane of Saturn's equator, and their orbits are pretty circular. Outer moons are more irregular, which means one or more of those three properties does not really apply to them, and this makes it more likely that they were captured into orbit around Saturn after the planet's formation. The 8 largest moons are thought to have formed along Saturn's equator from a protoplanetary disk of material. This resembles how the solar system itself formed. The planets all orbit in mostly the same plane and in the same direction around the sun because they formed from a disk of material that spun around the sun. Estimating a definitive, accurate number of moons for Saturn because it can be pretty hard to tell large chunks from small moons. Scientists have a similar problem with Jupiter. How do you determine what exactly is a moon? Saturn's largest moon, Titan, which has a pretty fitting name, is larger than Mercury. It's the second largest moon in the solar system behind Jupiter's moon Ganymede. Titan is distinguished by the presence of a significant atmosphere, which is denser than the atmospheres of all of the terrestrial planets except for Venus. It's the only moon in the solar system known to have clouds, a dense atmosphere, and liquid lakes. The other moons are all much smaller than Titan, and none except Enceladus have a detectable atmosphere. Enceladus has a localized water vapor atmosphere in the vicinity of its south polar hotspot. This is a region that's much hotter than would be expected from solar heating alone. It also exhibits structures that have been dubbed tiger stripes. Particles of water ice that form Saturn's E-ring are ejected in plumes from these tiger stripes. The surface of Enceladus reflects more sunlight than newly fallen snow, and the relative smoothness of this surface indicates recent activity that could have reshaped it. Mimas has a heavily impacted surface, and it also has one of the largest impact structures relative to the size of the impacted body. This crater is named Herschel after William Herschel, who was the one that discovered Mimas. Its diameter is about 1/3 of that of the moon itself. The moons Pan and Atlas are shaped like flying saucers. Iapetus has one side that is very, very bright and another that is very, very dark. A number of moons, like Prometheus and Pandora, are referred to as shepherd moons because they sort of keep the material of Saturn's rings in their orbit. Saturn has a lot of moons, way too many moons to cover in one video, and it even has other smaller moons that are constantly being created and destroyed within its rings. I think its moons should be just as well known as its rings, considering how damn many of them there are. And that's Saturn. Pretty cool, isn't it? I'll have a separate video on Saturn's moons, so wish me luck on that because, oh boy, do I have my work cut out for me. There's 146 moons, man. I can't talk about all of them. I'll just have to pick the most important, like, 5, and you'll have to live with not hearing about the other 141. I hope you enjoyed this little miniature exploration of Saturn. Like and subscribe if you had fun or you learned something. Thanks for watching, and have a good day.